Hello everyone, welcome back. This is Mr. Hussein Mosapi. So in this video, we'll be looking at a continuation from what we did the last time. So in our video, we'll be focusing on how to find the magnitude, which is the size, and the direction, which is what we call theta, of a given vector. Let us recall that a vector is simply any quantity that will possess both the size, which is the magnitude, and direction. Let's not forget this. Now, whenever it comes to us finding the magnitude and the direction of a given vector, you will realize that in most cases we'll be given components. Provided that we have the components of the vector, it is easy for us to find the size and direction. Without wasting time, let's do some trials that will help us understand how to find these magnitudes and directions of vectors. So, in our first trial, say we're being told to find the magnitude and direction of the following vectors. Alright, so suppose we have vector A, the vector of this question A, which is the first vector presented by capital F. Let's say it's having some components. Let's say its fx component is 24.1 newtons and its fy component is 12.01 newtons. Now, in order for us to find the magnitude, what we have to do is to use the formula for the magnitudes. So the magnitude of the first vector is equal to the root of the x component squared plus the y component squared. So the magnitude of any vector is equivalent to the root of its x component squared plus its y component squared. If we plug in our values, we'll be having 24.1 squared plus 12.01 squared. If we compute this, we'll be having the root of 725.0501. And if we compute that, we'll have the magnitude to be equivalent to 26.92675435. Now, if we round this off to two decimal places, we'll be having something as 26.93. Since the components are having the basic quantity, which is newtons, and even the magnitude, we'll have newtons. To find the direction, which is theta, the direction is equivalent to the tan inverse of the y component divided by that x component. Be mindful that this will be the absolute value of the y component over the x component. So theta is equal to the tan inverse of the y component, which is 12.01, over the x component, which is 24.01. If you compute that, you will get your value to be 26.57455959 degrees. Therefore, if I round off, this will be 26.57 degrees. Now, this will be my final answer due to the fact that if I look at the component, my fx component is positive, my fy component is also positive. So if I had to check the quadrant that it's falling under, I will move in my, since this is my y and that's my x, I'm moving my positive x and my positive y. So my angle is in the first quadrant, and all the angles in the first quadrant are always taken the way they are found. Let's look at a different condition. Suppose we have a given vector v having the components say minus 4.1 in the I plus 7.01, 7.0 in the j. Let's find the magnitude first. So the magnitude of v is equal to the root of the I component squared plus the j component squared, which is just the same as one writing it as the the vx squared component plus the vy squared component. So this will now be the root of minus 4.1 squared plus 7.0 squared. This will result into you having 65.81. If you compute 65.81 to find this root, you will find that your answer will be 8.1123368285. So if I round this off to 2 decimal places, I have 8.11. So now my vector here is velocity. Since I didn't specify, let's take it to be velocity. So this will be 8.11 meters per second. If at all are not given, we'll just say units. Then the direction theta will be equal to the tan inverse of the j component, the magnitude, the absolute value of the j component over the I component. So theta is equal to the tan inverse of the j component, which is 7.0, over the I component, which is 4.1. So theta will simply be tan inverse of that. You will get your value to be 59.64188454 degrees. Rounded off to 2 decimal places, you have 59.64 degrees. Now, you have to check the quadrant. Check the quadrant. Now, by checking the quadrant, you will draw your x or y plane, then check the directions of the I and j component. The I component is negative, while the j component is positive. So you're moving in the negative x, then moving in a positive y, which means that your angle is here in the second quadrant. And for the second quadrant, your final angle will be, let me call this prime, will be 180 minus theta prime, which will be 180 minus 59.64, which means that your final angle will just be 120.36 degrees, and this will basically be the direction of our vector. Alright, so we have another one. So we have a force vector, and the force vector is having 7.25 so fx, same minus 4.31 fy. Now you can always pause the video and attempt to do this on your own. I'll be using several notations of how the components can be phrased, and I want you to understand that there are quite a number of ways you can phrase the components, but I, for one, like to use the I and j component notation. But you can use the vector sub notation, where you say f sub x and f sub y. So to find the magnitude, say the root of 7.25 squared plus minus 4.31 squared, like that. Computing this on our calculator, we'll end up having something like 71.1386, like that. So the magnitude of this force vector will be 8.43437.016 degrees. Run it off to 2 decimal places, you get your magnitude to be 8.43. Since the force vector, we get newtons. Looking for our direction, which is theta, being equivalent to the tan inverse of the fy component. I don't even know why I'm forgetting to put the magnitude, the absolute value, sorry. So the absolute value of fy over fx. So theta is equivalent to the tan inverse of the fy component, which is 4.31 over 7.25. Then theta will simply be equal to 30.6 30.73075343 degrees. Round it off to 2 decimal places, you get 30.73 degrees. Now, let me call this theta prime first. We have to check the quadrants now. Check quadrant. Now, by checking the quadrant, like I said earlier on, you draw your plane, which is your XY axis plane, and you check the directions of your component. I'm having my fx component to be positive, but my fy component to be negative. So I'm moving in the positive x, then going in the negative y, like that. So I'm expecting my angle to be in this quadrant, and this quadrant is called the fourth quadrant. In the fourth quadrant, my final angle theta will be equivalent to 360 degrees minus theta prime, which means I have 360 degrees minus 30.73 degrees. This in end gives me 329.27 degrees, and that is the direction of this vector we're finding. Let's look at the last example. Say we have a vector A, and it has the components, say ax being minus 5.00 meters and ay being minus 9.00 meters. We need to find the magnitude and the direction of this vector. So I'll say the magnitude of a vector is equal to the square root of ax squared plus ay squared. Plug in the values, I'll get minus 5.00 squared plus minus 9.00 squared. As we all know, if we raise a negative value to an even power, we always get a positive answer. But if we raise a negative value to an odd power, we always get a negative answer. But in this case, our powers are even, so I have to get a positive answer. So the magnitude of A is equal to the root of 106. If I take the root of 106, I get 10.29563014. I hope you're moving with me as I am punching. I hope you're with the calculator and you're also computing on your own as you're learning. So the absolute value, which is the magnitude of A, is equal to, if I round this off to 2 decimal places, this guy here, you have 10 point, since the third number is equal to 5, you get a 1, add it to the second number, that makes it a 10, take that one, the first number makes it 3. So I have 10.30 meters. Now I have to find my direction. So theta is equal to tan inverse of ay about ax. So theta is equal to the tan inverse of ay, which is 9.00, over ax, which is 5.00, like that. So theta is equivalent to 60.945395.9 degrees. Round it off to decimal places, you get something like 60.95 degrees. Now you always have to check your quadrant in which your values fall under. So you check the signs of the component. I have my ax component in the negative, my ay in the negative. So I'm moving in my negative x, then going in my negative y. So I'm in the third quadrant. So in the third quadrant, all you have to do is to remember that if I call this prime, then the theta will be equal to 180 degrees plus theta prime, which would be 180 degrees plus 60.95. Then theta will be equal to, if I compute this, I get something like 240.95 degrees. Alright, thanks for watching. So this is how you go about finding the magnitude, which is the size, and the direction, which is theta. Though I don't really get the sense why most people call it theta, but it's theta. Alright, my name is Mr. Hussein Mosapi. If you have any queries concerning this video, or you have questions about this, you can always reach me on WhatsApp on the 9077-149-5252. Remember, small progress is better than no progress. And always strategize before you become a statistic, and let's try and push for that A+.